All right, I'm going to do number 11 here. So find number 11 in your notes. Now, yes, it's decimals, but you're going to do it the same way that we just did the last two examples. You're going to find which equation is already solved for one variable, take that expression, plug it into the other equation. So I'm going to take negative 2y plus 15. If that's what x equals, that's what I'm going to plug in for my x value in my other equation. So let's do that now. So 0.3 times negative 2y plus 15 minus 0.2y equals 0.5. And then we need to solve for that. So distribute your 0.3 in there. So negative 3 times, or negative 0.3 times negative 2. I know that 3 times 2 is 6, but since that decimal is there, it's going to be 0.6. So negative 0.6y, and 3 times 15 would be 45, but there's that decimal there. So plus 4.5 minus 0.2y. Combine your terms, so negative 0.6 and negative 0.2, negative 0.8y. Subtract the 4.5. And divide by negative 0.8. So 4 divided by negative 0.8 gives you a positive 5. And then we need to plug in to get your x value. So yeah, it doesn't matter necessarily which equation you plug in, but in this case, I'm going to plug into the bottom one. So negative 2 times 5 plus 6. So negative 2 times 5 is 10. Plus 15 equals 5. So in this case, x and y are actually the same value. Again, not required to check unless it specifically tells you to, but it's always good to go back and plug both of those values into both of your equations and say, okay, does this point of intersection or this solution make both of my equations true? Always a good idea to check. So that's number 11 with decimals. I'm going to do number 13 with you guys also because it is a fraction. So let's just do that one quick. All right, again, so you know you're in the substitution section. We know that that's the type of solution that we're trying to, or that's the type of method that we're using to solve for these. So when I'm looking at this, I see that the second one, or the second equation, is solved for x. So I'm going to take that expression and substitute it in there for my x value. So instead of 3x minus 2y equals 11, I have 3 in parentheses, that expression, minus 2y equals 11. So 3 times y over 2 plus 4 minus 2y equals 11. So distribute that 3 in there. And remember, that y, guys, even though you can't see it, there is a 1 in front of there. So it's 1y. So 3 times 1y is 3y over 2 plus 12, 3 times 4, minus 2y equals 11. So 3y over 2 is the same thing, guys, as 3 halves y. So if you have 3 halves y, that's 1.5. So what's 1.5 minus 2? Negative 1/2. Subtract my 12 and get negative 1. So there's 2 ways you guys can do this. You can say, okay, multiplying by a half is like dividing by 2. So the opposite of that would be multiplying by 2. But whenever you guys are trying to get rid of a fraction out in front, all you want to do is multiply both sides by the reciprocal. So if your fraction you're trying to get rid of is negative 1/2, you want to multiply both sides by negative 2 over 1. So the 2's cancel, the 1 cancels, you're left with y. And negative 1 times negative 2 is positive 2. So we have our y. We need to plug it in to get our x. So I'll just plug it into the second one. So x equals, y is 2, so 2 over 2 plus 4. 2 divided by 2 is 1. 1 plus 4 is 5. So our ordered pair, our solution to our system here, our intersection point, is going to be 5, 2. Our point of intersection. So if you see POI, that's what that means. Point of intersection, where your two equations would cross, the solution to both of them. So you guys have a lot to do. So go ahead and get started and let me know if you have any questions.